Hi, and welcome to another edition of Easy Theory. So today we're going to actually prove a really quick result called Arden's Theorem or Arden's Lemma. And the usage of this theorem or lemma is to help with the conversion of an NFA into a regex. So we had this idea of the GNFA method to convert an NFA or DFA to a regex, but we saw that the regex was actually quite big in relation to the size of the NFA. So Arden's theorem, or lemma, is going to help us with that. It's a different way to actually generate a regular expression for a given NFA. So what does this theorem actually say? So we have two arbitrary expressions, regular expressions, and if we make two assumptions, which are that the empty string is not generated by the first expression, A. It could be by the second one, but it's not by the first one. And suppose that we were able to relate A and B such that A is equal to some other regex, maybe the same, maybe different, union the first one on the left side concatenated with the second one. So if this is true, if this is possible to accomplish, then we can actually find a different form for A as being CB star. Okay, so it's basically like an equation that we have to solve. We have an equation here, we have to solve for A because A is on both sides, and this is the solution to it. That's what Arden's theorem says. So let's actually try to prove this. So we're going to make use of the fact that the empty string is not an A. So we are going to assume that this part is true. So we're going to assume this. So let's just write that down. A is equal to C union A concatenated with B. Okay. Well, we know what A is equal to this stuff right here. So what we can do is replace this A on the right side with this whole thing again. So this is equal to C union, well, stuff concatenated with B. And what is inside there? It's C union AB. I'm just copying, and maybe I should do that in a different color. So here I'm going to copy this all into here. And so let's actually expand this out. So it's going to be, I'll go back to the same color. So it's going to be equal to C, because this C didn't change, it's not connected to anything. Union, well, if we have something concatenated with a union on the inside, you can distribute the union across. So we have CB, and we have to have it in this order because B is on the right side here. And then union AB squared. So the squared here means B twice. That's all it means. Okay. Well, then we can try this again. Well, the only occurrence of A is right here. There's no A here, so we're still going to get C union CB union, and then we're going to copy and paste A again, or the contents of A into there. And so then let's do it this way. So this is going to get copied down to here. And what do we get out of this? So we still have the C union CB union. And then now we're going to distribute the B squared over the union here. So we get CB squared union AB cubed. Okay. And what can we see here? Well, we can actually prove what's going to happen in general. Well, for this A right here, the next term in the sequence is going to start with C no matter what. And we can guarantee that the power for the corresponding B is going to go up by 1 because this term right here contains a B. So when we apply this again, the power of B at the end is going to go up by 1, which is going to be attached to the C on the next step. So the next term here is going to be CB cubed, CB to the fourth, etc. So what we can write this as is being C union CB union CB squared union CB cubed, etc. But we can factor the C out because the C is on the front of every single one of these expressions. So let's factor it out. So it's C factored out, which is going to be epsilon union B squared union B cubed, etc. Well, we know what this is. This stuff, by definition, is B star. So therefore, this reduces to CB star. Okay, so that is a quick proof of Arden's theorem or lemma. So if you have any questions, feel free to put them in the comments. One thing that you can do as an exercise, which is actually kind of interesting, is prove that this expression is unique. So there's no other way to write this expression right here. There's no other way to write A as a combination of C and B other than this. Unless it's equivalent. There's unless you can derive it from the B star right here, but no other significantly different way of writing this. So if you want to support the channel, there are plenty of links in the video description. Please like and subscribe to the channel. It really helps us out. And as always, I'll see you next time.